The good news is because we now have a new z-score or z-value or a new formula to find that z-value based on talking about sample means, once we kind of plug numbers into that, we already know how to use our standard normal distribution chart. So if you look at this example, it says A.C. Nelson reported that children between the ages of 2 and 5 watch an average of 25 hours of television per week. And we're going to assume that variable is normally distributed. The standard deviation is 3 hours. Now they're taking a sample of 20 children between those ages. We want to find the probability that the mean of the number of hours they watch television will be greater than 26.3. Start by writing down your formula for your z-value. We're going to take the average of our sample, the mean of our sample, minus the population mean, and divide that by our sampling error, by our standard deviation divided by the square root of the sample size. Okay. Let's identify some variables. The mean, the average of our sample, is going to be this right here, 26.3. Okay, we want to find the mean of the number of hours they watch TV. Our population mean is given right here, 25 hours. Our standard deviation is right here. The standard deviation is 3 hours. And our sample size, our n, is right here, 20. Plug all these numbers into our formula. So we're going to take 26.3 minus our population mean of 25, divide that by our standard deviation of 3, divided by the square root of our sample size, which is 20. Basically, if you plug this into your calculator, the bottom number is going to be irrational and you get 0.6708 and so on. But if you divide them out, we get 1.94. So our z-value is 1.94. On a standard normal distribution curve, okay, remember 1.94 is going to be over here, and we want to find out what this number is. Okay, but remember, the probability is greater than this number. Okay, greater than the 26.3, which we put into a standard normal distribution or z-value. So if you look at your table and you look up on to the right of the mean, so on the positive side, we're going to look up 1.94. We get an area or a probability of 0.9738. But that doesn't mean the probability is going to be 97.38 because it's greater than. Just that old trick. We want all the values to the right of it, so we go 1 minus, and we get 0.0262 or 2.62%. Find the probability, not very high. New formula, but if we can identify all the parts, we know how to use the chart. We already know how to do that. Let's look at one more example. The average age of a vehicle registered in the United States is 8 years or 96 months. Now remember, for our formula, sample mean minus our population mean divided by the standard deviation over the square root of the sample size. Let's find our variables. The average age of all the vehicles registered in the United States, that's population, is 8 years or 96 months. Since everything else is kind of given here in month, I'm going to leave it as 96. The standard deviation is 16 months. They're taking a random sample of 36. Find the probability that I'm sorry, I put this in the wrong spot. Oh, so sorry. I said to you, knew something wasn't working quite right, that every vehicle in the United States is 96 months. So let's put that in the population one. Okay. Now for our average mean, we want to find the probability that the mean of their ages is between 90 and 100. So this is one of those where we want to do it twice. So let's start for the first time here, and let's start with 90. And let's go 90 minus 96 divided by all this good stuff down here. When you figure all that out, and again, be careful with the dividing, that works out to be negative 2.25. Let's do it for where it's 100. So again, I'm going to plug this number in, 100 minus 96, and divide by the same. That works out to be 1.5. All right, remember, we're dealing that standard, we just turn it into standard normal distribution. I'm going to have my negative 2.25, and then I have my 1.5 over here. So using our z-score, this negative 2.25, that correlates to 0.122. My 1.5 over here is going to correlate to 0.9332. We want the probability between them, so just subtract. You subtract those, you get, I'm going to write it down correctly. I apologize. I apologize for making these mistakes. That's actually correlates to 0.0122. I knew there should be 4 digits. So this correlates to 0.0122. When you subtract it, you get 0.9210 or 92.1%. So the probability that the mean of their age is between 90 and 100, notice it's not saying that their age is actually between 90 and 100, but the mean of their age is between 90 and 100. This all deals with the sampling, the means of the samples, is 92.1%. Here's your takeaways. Use your formula. Identify the variables. Plug it into the formula. Once you do that, what you found is a z-value. Use your chart to correlate the z-value to the area or probability that it matches up with in your table.